This is the speed of light. In this lab, we are going to be measuring the speed of light. To measure the speed of light, we'll be using marshmallows and a microwave. You'll also need a microwave-safe container and a ruler. The first thing that you're going to do is you are going to evenly space the marshmallows in the microwave-safe container. Now, I use these small marshmallows. You can use larger marshmallows. It doesn't really matter as long as they're evenly spaced and they're covering the bottom of that dish. The next thing you're going to do is you're going to take the rotating tray out of the microwave. We don't want this dish to be spinning while the microwave is on. The next thing you're going to do is you're going to take that container with the marshmallows and place it in the microwave. Once you've placed the marshmallows in the microwave, set the microwave for about a minute. That's a good time to get the results that we need. Depending on the power of your microwave, you might have to go a little bit longer, maybe 15-20 seconds. You'll know when you start to smell like burning marshmallow, and if you look inside, you'll be able to see some burn spots forming. That's a good time to stop the microwave. Now when you take the container out of the microwave, be careful, it's going to be a little bit hot. Now when you look at the tray of marshmallows, you'll notice there's going to be a couple of burn spots. This is how we're going to get the wavelength of the microwave. If we take a look at a diagram of a wave, you'll notice that there's crests and there's troughs. These are the spots where that wave has a lot of energy, and that is where the microwave is burning the marshmallows. Now normally anything that goes in a microwave is spinning, so whatever's in that microwave gets an even distribution of those crests and troughs. But because we took out the spinning tray, well, we're burning those spots. Now we can take the ruler and place it on top of the marshmallows and measure the distance between the burn spots. And if your tray is transparent and there's enough space in between the marshmallows, you could place it on top of some grid paper. That way you can measure the distance in between the marshmallows. Now this is the tricky part to actually get the distance in between the wavelengths. We're going to need to double the distance we measured. Now here's why. If we take a look at that wave diagram again, the crests and the troughs are going to be those burn points. So what we're measuring here is we are measuring the distance between a crest and a trough. We need to double it to find the distance between a crest and a crest. That'll get us the wavelength. We also need to convert this into meters. Now that we measured the wavelength of the microwave, we need to find the frequency of the microwave. That's usually found on the inside of the microwave. There's usually a little sticker that has all the information about that microwave, and the frequency should be on there. It's going to be in megahertz, and we're going to need to convert that into hertz. Now we have the wavelength of the microwave and the frequency of the microwave. We can use the wave equation to calculate the speed of the wave. And the speed of the wave for a microwave is going to be the speed of light. Now that we have the calculated speed of light, we can compare that to the actual speed of light. This is the actual speed of light, and we can use this equation to calculate the percent error. The speed of light is so quick that any slight difference in measurement is going to result in large errors, especially when we're measuring the distance between the burn spots. So once again, this is the speed of light.